Have you ever wanted to control both the speed and direction of a motor using an Arduino? If so, you're in the right place. Welcome back for lesson 7 of the ultimate guide to Arduino automation. In this video, you will learn how to use the analogWrite function of the Arduino. Analog output is great for controlling things with different power levels. Think of it kind of like a dimmer switch on a light. Take a look at this Arduino here on the screen. You'll notice a little squiggly line next to digital pins 3, 5, 6, 9, 10, and 11. These are the pins capable of analog output. They can create a simulated voltage between 0 and 5 volts by pulsing on and off for different durations, hence the name pulse width modulation, or PWM. For today's video, we'll be using this 12-volt gear motor, an L298N motor controller, a Rev 3 Arduino Uno, a 12-volt battery, and the same joystick that was used in lesson 5. Now before we write the code, let's go over the schematic really quick. You'll see the 12-volt battery here is connected directly to the L298N motor controller, and that board is directly connected to the motor using pins out 1 and out 2 to the red and black of the motor. One of my favorite things about the L298N is that it has a 5-volt output that can power the Arduino directly, so you don't need a separate power supply for the Arduino. So connect 5 volts to 5 volts on the Arduino, and also ground on the 12-volt battery to ground on the Arduino. Over here on the joystick, one side will go to 5 volts, the other to ground, and the center pin will go to our analog input 0. And then digital outputs 5 and 6, those are both capable of pulse width modulation. So we will connect those to pins in1 and in2 on the L298N motor controller. Okay, let's write some awesome code here. First off, we're going to need an integer for our motor speed. I'm using an underscore because you're not allowed to have spaces. I'm going to set that to 0 initially. And then here in the void setup, we're going to do, if I can type right, pin mode 5 as an output. And we're going to do an analogWrite command for pin 5 at 0 power to start. And we're going to copy and paste this and do the same thing for pin 6. Okay, down here in our loop, we're going to say motor speed is equal to our map function that we used before in previous lesson, analog read of A0. We're going to map it between 0 and 1023, which are the maximum values for our inputs. And we're going to put negative 255 and 255. Now the reason I'm doing this is analog outputs are anywhere between 0 and 255, and the negative sign will help us know the direction we want the motor to turn. Now for an if statement. So if the motor speed is greater than 20, and I'm using 20 as my deadband. If you remember in a previous lesson, we talked about why that's important. I'm going to write analogWrite to pin 5, our motor speed. And then on pin 6, we want to write 0 power. That way it will spin in one direction only. Okay, and we're going to have a similar statement, else if motor speed is less than negative 20, other side of our deadband, then we'll do the following. We'll do analogWrite, and this time pin 5 will be 0. And pin 6 will be motor speed, except because it's a negative number, you can only output positive numbers for analogWrite. We're going to say negative motor speed, which will change it back to a positive number. And then, if we're between negative 20 and 20, we want both analogWrites to be 0 so that it doesn't move at all. All right, so let's hit the verify button. Make sure that we don't have any errors. And go ahead and upload our code. Now you'll notice that the Arduino is not connected to the computer. It's getting its power directly from the L298N. All right, so now if we move our joystick, we should be able to turn the motor. And as I push the joystick harder, the speed increases. Same in the other direction. I can go slow, I can go fast. Everything's working great. If you've enjoyed this lesson, be sure to tune in to the next one where we will be going deeper into motor control as we talk about motor encoders. Motor encoders are really cool because they let you determine the direction that a motor is spinning. They let you measure the speed the motor is turning, and they also keep track of the ultimate position of the motor. Really interesting stuff. Hope to see you back for lesson 8.